Hello everyone, welcome to Core User Group. I'm Nalin Vilochan, Next Gen Voice Solution Leader. So, what is CNCS? CNCS is Cloud Native Communication Suite. It's a suite of product from Nokia, which is providing IMS functionality. On the left-hand side, if you see, there are many elements today which are distributed and independently managed, which makes the IMS network very complex. What we have done in Nokia that we have innovated and created a product called CNCS, which has all these network elements together in a single CNF, which has many benefits, which I'll explain later. At the same time, it provides all the 3GPP specific interfaces as is. Okay. We have focused mainly on simplification, operations, and hardware cost saving. Key advantages of CNCS. In summary, CNCS brings the complete box into a single CNF. As solution is with distributed system to a combined system, we have seen 20% hardware reduction. CNCS can be managed completely with a single life cycle, even for installation, termination, upgrades. CNCS supports reduced integration points, which eases the pain of integrating the VoLTE network. CNCS supports single OM for all the FCAPs. It has integrated diagnostic tools. CNCS provides higher reliability because of the integrated architecture, and it is highly scalable from 100K subscribers to 4 million subscribers. So these are key advantages of CNCS. CNCS has two variants. One CNCS variant is called CNCS BCS, which is focusing on business use cases, and CNCS MCS, which is focusing on mobile use cases. The main difference is the telephony application service, which is inside the system, right? One BCS has a BCS specific task, and on the MCS we have MCS specific tasks, which is mainly providing all the functionalities of IPSM gateways and SSF and USSD functionalities. CNCS supports maximum 4 million capacity in a single CNF. If an operator has a bigger capacity requirement, we can have multiple CNCS network and integrate them together to bring a bigger capacity. So coming back to today's demo, CNCS support advanced integrated and automated in-service upgrade for the whole elements inside the CNCS. So main three takeaways is in-service, it is doable within a single maintenance window, and it support flexible upgrade functionalities, like we can have a complete CNF upgrade, we can have selective microservice upgrade, or we can also have a selective network function upgrade inside CNCS. As part of today's demo, there are 3 types of demo available. A complete CNCS upgrade, which takes approximately 2 hours for all the functions inside CNCS. We can also support single network function upgrade, which depending on which network is upgrading, we take about 20 to 40 minutes. And a single microservice upgrade, which is mainly used for corrections and security patches, we take about 5 to 15 minutes of upgrade. Okay. In essence, it is fully automated, very flexible, and meeting all the customer needs for upgrading in service. So let's go into the live demo. CNCS lifecycle is managed by the NCOM, Network Operation Manager. And here you can see in the screen that there is a NCOM page where we have selected one CNF to be upgraded. On the top, you can see various actions which possible. I'll select one action, which is for updating the network. So by selecting this, NCOM is trying to fetch the details of this particular CNF, and then it will present with an option what all options are available. Now you can see in this page, the CNF current state is loaded, where you can see that target current version is 167, which is the software which we are going to upgrade to a newer version. Okay, it's 168. All the details about what are the different packages currently active on the system is loaded here. Okay, so let's proceed with the upgrade. So Nokia provides artifacts for the upgrade, right? So let's take that artifact. When we load this artifact, right, it provides you different kind of service available. So this is automatically selecting an upgrade because it's an update service, and then it loads all the versions which are supposed to be upgraded to. This is a page where we can review all the artifact and all the upgrade. Then we continue. So what Encom is currently doing is trying to check whether the version which is getting upgraded has all the relevant artifact in the repository or not, whether the charts and the images are updated or not, and then it will present with an option where we can review it and then proceed further. Now you can see that all the services which are getting upgraded is available here. It also fetches which cache this CNF is located and in which namespace the CNF is installed. So we review and continue. Here it provides clear indication that this is what we are going to do. We are going to update the CNF. Now in this page, what Encom is doing, it is fetching the details from the active installation. It checks all the microservices, their versions. It does a diff and finds out that what action user has given, and then provides you a summary where you can review which microservice is getting upgraded. Do you want to select or check different options available or not? And that is where the key difference is, that whether you want to upgrade the whole CNCS or you want to upgrade the single NF, or inside the NF you want to upgrade a single microservice. And all this functionality provides you a faster way of installing a newer software package via Encom. So you can see here that this update what we are doing, the only impacted service is CFX service, which is call control function. And inside that, what all services are getting updated, we can see. We can choose to upgrade the whole CSCF by selecting all, or we can go and choose a specific service which we'll be doing today for ICSCF, and then I select that and then move forward with that particular upgrade. Okay. In this page, we will see the summary that ICSF is getting upgraded, image, what version of image has changed, and then we can instruct Encom to execute this upgrade option. Okay. While it's loading, I wanted to show you that there is a performance load is already running for 1 million subscriber registered, fully active, and these are the active dialogues on the system. So here you can review what is going on in the CFX service. ICSF is getting upgraded, and then all the other charts remain same. If a user wants, they can select this health check what they want to do, and it's optional service. We can uncheck it. We go and click execute, and then instructions will be given to Kubernetes to execute this upgrade. So what now Encom is doing, it is trying to create jobs and instructions to Kubernetes, which all microservices need to be upgraded. And then once a job is created, we can monitor the job and see how it is progressing. Encom will spawn different actions of checking the health of the pod, identifying which pods need to be scaled. It scales itself for creating forked requests towards the Kubernetes, and then waits for the response from the Kubernetes, and then gives the feedback to the user in the GUI. So that is what is currently going on. It is forking different requests towards the CNF and trying to upgrade the microservice which you have instructed to. This upgrade is, since it is a single microservice upgrade, it should take approximately 5 to 7 minutes to upgrade the whole microservice. Okay. We can monitor the upgrade progress here, or we can monitor the progress into CLI as well, where we can see what is the version deployed, what is the current version of the microservice. We are trying to upgrade this ICSF deployment to a newer version. Currently it is 6. After upgrade, it should become 7. There are total 4 pods. So as per the pod disruption budget, 50% of the pod will go down and will come up with a newer version, and then next 50% will go down and it will come up with a newer version. So as you can see, it has progressed further into upgrading the system. Different microservices are being checked, whether they need to be upgraded or not, and then accordingly instructions are being scheduled towards Kubernetes. So we can see here on the top that CFX microservice is now scheduled for update, and then we'll see further progress here. So you can see in the screen that pods have started terminating. 1, 2, 3, 4. So 4 pods, 4 out of 2 has started terminating, and new pods have started coming up in the init phase. And the deployment, you can see that this ICSF deployment is in pending upgrade. So once this is terminated, new instance is coming up here. they'll become active in the running state, and then remaining 2 instances will go down and they'll become active. So let's wait for it. You can already see that the version has changed from 6 to 7, which is the target version, and the state is pending upgrade, which is currently ongoing. So first container of ICSF has come up, remaining 2 are in progress. And the amount of microservice, the number of microservices which need to be upgraded depends on the pod disruption budget, which is currently set to 50%. Based on the customer need, this can be adjusted, changed on the fly. So we can see that the pods have come up and in running state, and hence new pods are getting terminated. At the same time, older pods are getting terminated and newer pods are coming up. So out of 4, 2 are in running state and 2 are in terminating and 2 are in creating state. Now you can see that all older pods had been terminated and new pods are coming up, which takes about 2.5 minutes to completely come up in ready state. Right now, these remaining last sets are in pod initializing state, and then they'll move to container activation stage. So now the remaining last 2 pods have gone into 2x3 stage, means 2 of the 3 containers are up and running. Then it will wait for another last container to come up, and then all of them will be in running state. You can see here now it has gone into a deployed state. Previously it was pending upgrade. Now that has been completed. The version is set to 7 for the whole deployment, and you can see all the microservices are in running state. So from Kubernetes point of view, upgrade is done. The feedback is given to NCOM to update the status, update its database, which takes few seconds. You can see all the jobs are successful. So NCOM is now trying to checkpoint all the state into the DB so that subsequent upgrade or any other LCM action can be done, and using the state, it can manage the next step. So if you look at the screen here, this is the action which was done. So CSCF service, we have upgraded ICSCF, and it approximately takes 6 minutes 39 seconds to execute it. So from Kubernetes point of view, the system has been already upgraded, and right now NCOM is trying to check all the other services which need to be upgraded or not, and accordingly executing. You can see now the whole update has been completed, okay, which took approximately 11 minutes and 16 seconds. Now this is the state where we have upgraded the microservice, which takes about 5 to 15 minutes, depending on which microservice you're upgrading. Okay. Now let's proceed with other discussion. So these are the 3 possibilities. We demonstrated this. Within 5 to 15 minutes, we can upgrade the single microservice. The same functionality also can be used, same flows can be used to upgrade a whole CSCF or SBC or MRF or TAS, or we can also do the complete CNCS upgrade in 2 hours. Okay. What is in store for CNCS? So CNCS is constantly evolving to a newer technology. We are delivering CI/CD and continuous test with this CNCS. We are also working on trialing version of IMS data channel, 5G new calling. We have also developed many features functionality on N5 interfaces which are already available, and we are evolving it further. We are also working on integrating ISBC inside CNCS. We are also evolving CNCS with future SBI interfaces like N70, N71. And we are also working on supporting vTapping, which can be used to tap either the N5 or SBI interfaces, or also the internal networking PCAPs. Nokia CNCS is first in industry. It has focus on IMS network simplification. CNCS is supported on multiple CAS like AWS, NCS, NCP, and other Kubernetes compliant versions. CNCS supports fully automated and integrated LCM. Thank you for watching.